I'm Dan, and
Hi, Dan.
I'm one of the guys that works here every day. Abraham, you guys probably met Abraham over there. Together, him and I, our duties here are just to run the place. We're making char almost every day. If we're not making char, we're cleaning something out and fixing something, getting ready to make char the next day. So really, that's what we do. That's our full-time job now. And this is the equipment we make it on. I'll start with where the wood goes that you're ultimately going to make char out of. Each one of these is the retort unit. So this is, like Bob said, we've got 3 retorts. These guys look like dumpsters here. This one, if you poke your head in there, you can see some char that we made last Wednesday. We ran 2 of these last Wednesday. So we got this one full of char, this one's full of char, and on the end there, we've got that one loaded up with good fresh slab wood, and we're probably gonna run that on Tuesday. So looking at the energy path here, we start the whole process with these. Like Bob said, we've got 2 gasifiers that we use to start. This is one of them. And the other device over there, exact same thing. We load these up with wood chips. We start it through this port, and we get a good fire going down here in the burn chamber. And that gas moves from the burn chamber down through some channels underneath each one of these retorts. So there's if you can follow the gas, imagine a channel all the way underneath that gets down to the end, and then it takes a U-turn, comes around the back of this, and then through another channel through the floor, and it goes up through the flue and out through the chimney. Now, as it makes its way out through the flue, it's passing through a big water to air heat exchanger. So these green jackets over here, those are big shell and tube heat exchangers. So that's our first opportunity to heat water, that we're using elsewhere for heating all kinds of stuff out here. So while that hot energy passes, underneath the retort, we're just cooking it just like an oven. And the inside chamber here just gets hotter and hotter, and it burns off all that moisture that we talked about, and starts to pressurize. So when it pressurizes and gets to a certain temperature, it's what we call going exothermic. It starts to produce its own wood gas that we then reuse, and it makes its way back around to the burn chamber, and we use that to continue the process. So in a lot of ways, it's just like that steel unit over there. This is our outside drum, and that's our inside drum. So pretty cool thing we do is take this gas that comes out of these retorts, it's the smoke at that point, it's the dirty gas, and we condense it. And if you guys look back behind here, we can walk around to show you a little more carefully. It's another shell and tube heat exchanger, basically. Stainless steel this time, where we pass this gas across cold water, and we drop out all the condensable gases, and we collect them into the tanks over here. So you guys see all these plastic totes. That's all full of condensable gases, pyroligneous acid, wood vinegar. It's a lot of tar, some oil in there. It's pretty cool stuff. Bob told you all about it. So returning back after the condenser, we come down through this fan here, and that is all of our non-condensable gases. That's your hydrogen, carbon monoxide, a little bit of methane. Anything else?
A couple hundred other things.
Yeah, mostly that stuff. Makes its way back into the burn chamber, reburns, and follows that same process. And then at this point, we're just taking that and we're capturing it again on the way out, heating water with it. So these black rubber lines that you see coming down from the ceiling there, those carry the water. It comes down and gets heated, and then it returns back into the mechanical water storage room in here. So it's gonna be hard for us all to see it, but we can walk in there and I can show you around.
So how do you get the char out of here?
Good question. So this goes to Bob's question about scale. Guys were asking, I think, a better way to crush the char. Well, we operate on such a big scale that we can afford to use one of these big, it's basically a leaf vacuum, that we jump in there and we vacuum it out, and it grinds it on the way out, and we capture it into those big giant super sacks.
So you kind of chop it up in here and then suck.
Yeah, we vacuum it through a chopper.
The vacuum itself grinds it up on the way through.
Yeah.
And we add liquids at that point too. so that we
Keep the
don't
dust off.
get the dust all over.
Since there's a forced air element, I mean, how do you stop the process? Because won't it eventually burn this?
No. Well, the channels are separated from the tub underneath. Yeah, if we had one empty, I could show you, but the tub actually stops about right here.
Okay.
Yeah,
And there's enough heat just in that to bake all this stuff?
to start it. Really, there's enough heat just to start it, and then at that point, this kind of burns itself. And we're taking the heat off of this and sending it through. It's about an 8-hour process.
What do you mean this burns itself?
Well, it pyrolyzes. It's everything in the wood besides the char is cooking out.
But there's no combustion.
There's no combustion in this chamber.
No oxygen.
No, that's what we're really avoiding with these.
Big oven, basically.
Big oven, exactly. Yeah, big closed oven.
And I have proposed that this is the future of the burial industry.
Yeah.
I totally want to go, but right? And then you put the biology in the person, right?
The viewing is of a charcoal person, right?
And then you put the biology in them, right? And then you put them in a garden.
can be the
and that's a
first.
special
I'm ready,
garden
I'm
that they
ready.
help fertilize.
Ready right now?
Yeah, I need to start taking contracts with the mafia.
No, I'm not that kind of ready. But I'll sign the forms now.
All right, good.
Hey, I'll volunteer. I'll be the first charge.
pay ahead, Bob.
Right, natural
There you go.
burial system. There you go.
Crowdsourcing.
And then I'm
One of the things that isn't real obvious in this, there's 2 inches of very fancy insulation between the inside and the outside of this. That it's the same material they use on the bottom of the space shuttle. So while we've got 1,000 degrees in here, you can still do this. It's hot, but it won't burn you. It's probably, 150 degrees on the outside.
Yeah, I'm actually warmer standing around that 55-gallon drum than we
Yeah.
are standing around this machine when it's operating.
So a lot of what we're doing is trying to contain the heat and contain the gases, and of course control when they get oxygen so that they burn or don't burn. We're going to take this and mix it and inoculate it and condition it and then sell it. So this is only going to be a portion of the bag that you're buying because it's mixed with other stuff. But
No, more like 50.
when I'm doing economic equations on the business, I think in terms of $1.50 to $2 a pound for the value of the biochar portion of it is what I'm shooting for. And a lot of people in the industry say I'm crazy. They can buy it for $250 a ton. And I always say, how far can you move it for $250 a ton? And how far, to bring the other stuff in, and what kind of machine have you got and how many tons? And there's a lot of things in that economic equation that make it profitable or not profitable, as we're finding out. And that's a big part of what we're trying to do here, is to prove that this will work profitably so that more people will do it. Our hope is to inspire lots of competition. And I believe we will, and I believe we are.
Have you done any startup costs of this, or is it too new to look at it that way?
Well, it's also a very good question, but that also depends on where you're doing it, just the land that it's on. In New England, 3/4 of an acre in my neighborhood goes for $300,000. So it's a little hard to justify just that piece of it, much less all the rest of it.
Yeah.
There's so many variables involved. The regulatory environment that you're working in is a big one. How long is it going to take you to get through all the red tape in order to do what you've got to do here, in order to make any money at doing it? So Dan will show you in small groups, and you want to see in the control room in there how much goes into trying to cycle the energy here.
Yeah, these are our 9,000-gallon tanks.
how many?
9,000,
How many of them you got?
2 of them. Yeah, you can just kind of step over our ladder back there, get to the next one. And so there's rubber lines that are coming in from outside. They're coming down over here and interfacing with just this one single loop. So this is where heat's going to enter the system. And At that point, once the heat enters the system, we can either go and deliver it to the tanks and start warming up the tanks themselves, or we can take it out to these individual loads throughout the facility here. So going back into the kilns that you guys were sitting in, these are the big heaters out in the kilns, and these little pumps over here, these are the floor heat. So we've got plastic tubing in the floor as well. And over there we've also got a large pump that delivers low temperature water out to the greenhouse to heat the greenhouse soil. These pumps, this guy right here is in place for high temperature heat out in the greenhouse as well.
There's some fan units out there.
Yeah, it's got future use over there. We haven't set those up yet, but we have the option. These guys are for future refrigeration that we're planning on doing out here. Pretty exciting stuff. So they're going to do absorption cooler in the berm over here. So we'll just be taking these lines and running directly outside and be able to actually do a walk-in cooler with power from waste heat.
Cool.
Pretty
How
fun
hot
stuff.
does your water get? How hot are you storing it at?
You know, it's all about how much we're producing. We've seen it as hot as 150, although we expect to get it up to 180 and keep it there. Get much hotter than 180 and we start to look at dumping heat.
Right.
You know, and hopefully by that point we're finding other ways to use that gas.
Because you're using a lot of PEX pipe here for this.
Yeah,
Distribution
yeah,
lines,
PEX
yeah.
is still fine. Yeah,
So
PEX is good up to.
180 would be a good time to start thinking about dumping.
And PEX is even fine for I think 250 as long as there's no pressure on it.
Yeah.
And we've got no pressure on the system. It's completely open to the atmosphere.
You
way in here.
talk about your heat exchanger. Are you running water through out there on the exchangers? You're not running
Just water.
This is your first winter, huh? This will be your first winter going?
Yeah, we started in March, so we did a little bit of heating very early on, but we're just getting into, you know, that's our big challenge is providing consistent heat for the greenhouse.
And provide consistent heat through your heat exchanger so they don't freeze over the weekend or something, right?
Exactly. Well, we got freeze protections built in over here. And
Recirculate back some warm water through them.
yeah, these guys are pretty cool. When they cut down to 35 degrees, we'll cut on these pumps and they'll circulate water up to 38. So
Back through your exchangers.
back through the exchangers. Yeah, we've got freeze protections basically everywhere except for the greenhouse. And those lines are underground, so hopefully that's good enough for us.
You got the glove with the holes in it. Bob's? But yeah, those are my gloves. I know where that hole is. So Bob's coming with some water. Usually you'd want to wait until it's, you know, completely cool, but you can see, so while you guys were meeting, this turned into a nice batch of charcoal, biochar. And you can see if you waited, it'd still be cool, but here's Bob with the water.
Actually, that's not about
See the minerals.
It's the wrong message.
Biochar sauna.
Hey, wait a second, that's it. The biochar sauna, you named it. I know lots of people up in Southwest Virginia that got outdoor saunas.
After they do the sauna, they eat some char. They have the whole health regimen.
This is there's no browns in this at all. This is all the volatiles were burned off. You can see, I don't know if any of you were paying attention, but you know there's an occasional burst of gas from this when the wind kicked up and blew it out before it could be burned. But it was a very clean burn. There's hardly any volatiles left in here, just pure carbon. And if you're at home, how I started making char doing this, you just kind of crush it up. I'd put it in another barrel and smash it to pieces and mix it in some compost and put it on my gardens. And that's
Lots
a
of soil
good amount.
scientists tasting the soil. Okay,
Anybody-
I need this one.
We're gonna start putting it in the chicken house.
Put it in their feed.
Yeah.
They feed it to pigs. They feed it to pigs. Love it.
3% in the feed, I think.
If you put this out in the field with the pigs, they'll come over and eat it like potato chips.
Yeah, they said they'll pick through the food to get to it. They really want it. They know it's good.
Here's a piece of our molding from the millworks place.
Would that also be a good way to charge it? Just put it in your chicken pen and let the chicken scratch it in, and then when you clean the litter out, it's
Yeah.
already done.
And it's soaking up the ammonia. What's all the smell coming off of chicken manure? It's ammonia, right? So we're putting that nitrogen back in the soil instead of letting it into the air.
Well, nitrogen's so volatile too. You're capturing it and keeping all that the available nitrogen source for the plants, tying it up with the char too, as well as the smell.
There's a lot more to learn about it. So,
And you can make
once
it at
again,
home.
we're here to inspire you to go and learn more and try it yourself. And then share it with everybody else, including us, so that we can learn from you.
When you're, I've helped a friend of mine do it a couple times. He doesn't use the inner barrel. He doesn't use the retort. He just fills this thing up, does a top-down burn. We light the chimney. It takes it about an hour or a little over to burn through. Is that a decent process?
Well, there's a...
I mean, his stuff looks about almost identical to that. He doesn't get quite as much per burn, though, because I guess he's losing it. And plus, you got to watch it and hit the, you know, you got to put it out before it burns it all up.
Right.
You know, it's more of a labor.
Like I said before, there's hundreds of ways of doing this. What I like about this one is the labor, the little amount of labor it takes. There's a lot of gasifiers. There's a thing called a T-Lud that's very popular. It's a good way to make biochar. It's a gasifier. In other words, it doesn't have a sealed inner chamber. You're actually smoldering the wood through, releasing the gases and burning them, hopefully, in a T-Lud. T-Lud stands for top lit updraft gasifier.
That's what Walter does.
And you can make those as little camp stoves, and they'll run on wood pellets or wood chips or anything you want, but you've got to be able to be there to turn it off. Either cover it up and smother it or wet it down. This one, if we hadn't bothered to open this right now, we could have left it and let it cool down until tomorrow morning and opened it. We wouldn't have to put water on it. We only put the water on because we wanted to show you sooner rather than later. PhD Kelly Roberts from Cornell, who is also a grower, has an organic farm, and I've been communicating with her about doing a life cycle study on our system.
Yeah.
Because that's where, if you really want to go there, now you got to get into how much fossil fuel did it take to make that can, okay? And how many burns am I getting out of that can? How many pounds? If you want to really get into it, you can. And she's the kind of person that can do that. That's what she does, is life cycle studies. So we'll be working on those questions and trying to make it so that we can point to real scientific evidence that proves what we're doing intuitively here. But I think John's reinforcing, follow the 4 rules. We turn it over to Pat, who's going to take us into the real reason we make biochar, for growing great food, and he's the guru of that.